So now what we're going to do is we're going to try something else. All right. We're going to try, let's say there's a ball that is launched with a horizontal velocity, or initial velocity of, let's say 10 meters per second from a height of, let's go ahead and say 30 meters. And I want to know what is the impact velocity. So I want to know, how hard does it hit the ground? Well, what's going on here is you got to keep in mind there are two components of this velocity. So the ball's travel is going to travel on a parabola and it's going to hit somewhere like this. It's going to be moving sideways while at the same time moving vertically to create some overall velocity in that direction. So we need to calculate that. Now, believe it or not, this is not all that difficult. It's just a simple vector addition is what it really boils down to. So if we take a look here, we know that eventually what's going to happen is we're going to have some, we're going to have some velocity in the y direction. So we'll have some component in the y direction. It'll have some component in the x direction, and that will end up with some resultant velocity. Okay, so this is our resultant velocity right there. We'll just call that v. We know that the x component should be 10, right? Because it always moves at constant velocity. So down here we know that that is going to be 10 meters per second. That's not going to change. So now all we got to do is we got to figure out, okay, so what's this y component? Well, we know that we have an equation like this. V naught squared equals 2 plus, that's supposed to be a plus, sorry, try to erase that there a little bit, plus 2a, and again, instead of using delta d, I'm going to use delta y because we're talking about dropping here. That's going to go away to 0, and so what I end up with is this is going to be 2 times g times my delta y.
Down 2.
Oh, you're helping? Okay, sorry, that's my 2-year-old. She's informing you all that she's 2 years old. Say hi, Marilise.
Hi.
Say it louder. Say hi.
Hi.
There you go. Okay, so that's my 2-year-old. She's helping. So is my 5-month-old. So if you hear her too, that's what's going on. All right, sorry, we're getting distracted here. But anyways, we're going to have VF squared is going to end up equaling 2 times a negative 9.8.
Do that, Daddy.
It's all right, sweetheart. I got it. And scooch over a little bit.
Okay.
And this will end up being negative 30 because that's how far it's fallen. We'll need to end up taking the square root of that. So let me grab the calculator real quick. And what we'll get is 2 times 9.8 times 30. And then we will hit the square root button. And I get 24.2. So the final velocity is 24.2. Now remember, this is where vertical stuff comes in. Remember, whenever you square root something on your calculator, it only gives you the positive root. It's your job to know better and know that it should be negative, so it actually should be negative. So we come back over here to our vector diagram. We don't need the negative because it's got an arrow drawn down, so we know that's negative 24.2 meters per second. And then now I've got the two sides of my rectangle, so now I can just do a little a squared plus b squared. And I get equals c squared. And I get, for the whole shebang, the velocity is 26.2 meters per second. Now, if we need to calculate the angle, the impact angle, I'm going to calculate this angle right here. So that's what theta is going to be. I'm going to inverse tangent my opposite over adjacent, my opposite being 24.2 over 10. And I should get my angle here. And so my angle ends up being 24.2 divided by 10. And I get 84.3 degrees is what I'm getting. Which makes sense because it's moving down much faster than it's moving sideways. And so we would, put that and say with the horizontal there. All right.